I want you to be more energetic than the morning session. Okay. So, so the topic now for discussion is process performance indices. So the catchword here is performance. Tell me, is there a difference between the words capability and performance? A normal English meaning? Are they same or different? Are they same or different?
They're different.
Different, different. So you know the meaning of being capable. You also know the meaning of performing also. So which one you really want to achieve? You just want to be capable, or you also want to be performing? Which is most important to you?
Capable.
Performing.
Must be capable.
Cpk.
Capable.
So
You just
both,
want to
sir.
be capable.
Both capable and
So
performance.
so so you, when it comes to a comparison, you are least bothered about the performance and you are most concerned about the capability. Is my understanding correct?
So first stage is first stage is capability, which should be a capable first, and
Okay.
use the capability in performance.
Okay. Use the capability for performance. Finally, when it comes to the customer, what matters to your customer? Your
Performance.
capability is
Performance.
Only
Performance.
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 business is always around the customer satisfaction. So if I want you to make a choice whether focus on the capability or focus on the performance, you must focus on performance if you are really concerned about customer satisfaction, because it is your performance which your customer will be witnessing, not actually your capability. All of you understand? So Pp, Ppk are the indices which can help you understand your performance with respect to the customer requirement. You can also consider your Pp, Ppk as long-term capability. Long-term capability, isn't it? Cp, Cp, Cpk actually is a measure of your current capability. Current capability and current performance, yes, it can be same. But then long-term capability and performing at the same level over a long run is not that easy. It requires a lot of disciplined control, isn't it, on your what do you call the daily routine. Then only you can be capable even in the long run. So just to help you understand, capable. Let us consider the skill of singing. We wanted to sing a song. So we can always sing a song inside a room, particularly inside a bathroom. We all used to sing, right? So the song will be so nice to hear. However, if you want to sing in front of an audience of 1,000 people, and now it is not as easy as singing a song inside a room, isn't it? So singing a song inside a room indicates your capability. But the ability to sing a song in front of 1,000 audience indicates your performance. So which is important to you? What is that you actually wanted to build? You wanted to build a skill to sing a song just inside a room, or you wanted to build a skill to sing a song in front of 1,000 audience?
Front of thousand.
That means you must, in business also, you must try to achieve a higher PPPPK, not just CPCPK. Of course, ability to sing a song inside the room could be a starting point. But finally, what matters to your customer is your performance on the dais, the performance on the stage. So, and again, considering the same scenario, which is very much controllable. Your short-term capability is very much controllable, or long-term capability is very easily controllable. Which is easy to control?
Short term only.
Short
Short
term.
term only.
In short
CPCPK.
term, see, because if you consider the factors within a particular room, it is much easier. You understand all the factors, everything that appears within your room. Yes, you need to have a good control over it so that you can sing a song very nicely. But when you put yourself in a scenario of 1,000 audience, will you be able to see some additional factors now? Earlier, there were no audience. But now there are real audience, 1,000 people. And there could be what you call the environment is completely different. So now you should be able to better control your nerves. Otherwise, your performance, may not be as expected. So same is the logic. Producing good parts for 1 hour is not a difficult job. Ability to continue producing good parts for several thousand hours is the real challenge. Yes or no? That definitely requires a very higher level of disciplined approach and discipline to follow the control plans in a very effective manner. All right. So in the long run, what are the additional factors that can come and play or that can come and affect your process in the long run? In 1 hour, nothing will come and affect. Whatever that can affect, we could directly see. But in a long run, there can be few other factors. Can you please point out few additional factors which can come and affect your process in the long run?
In long run, ambient itself may be varying. Let's say this
Come.
today is the temperature is 29 degree. And after
Okay.
5 days, it start increasing. Humidity also
Excellent
start
example.
increasing.
Excellent example. So the daily temperature, the environmental conditions may not be same. Today it can, tomorrow's temperature can be different from today. Morning temperature can be different from evening. Next week temperature can be completely different. We are not actually including those factors as part of our study. Yes or no? While performing a short-term study. Okay. And
Even
what could be
even in that, so there will be definitely input also. So the input at some other location may be getting manufactured. There also some variation also may be coming. So incoming
you mean
source
to say
variation
raw
always there.
variation in raw material, isn't it?
Yes, yes.
Because in one day you will be consuming, already available raw material only. But over a week, over a month, over a year, over a long term, you will be
Correct.
replenishing raw material. So there could be a chance of variation within the raw material.
Yes.
Yes or
Even
no?
sir, yes, yes. Sir. Even sir, some of which are the common causes, which is inherited from the machine or the system itself. Over a period of time, that common causes also may increase because
Yeah,
machine
you
itself
mean to
keeps
say your
running.
machine can undergo wear and tear,
Yes, yes.
which is difficult to capture in your short-term study. But definitely in a long term, your machine will undergo wear and tear and performance may not be as expected, or as you have seen in the short term.
Yes.
And some of your operators might even leave the job. You may be appointing some new operators, right?
Yes.
And
So,
competition also, sir.
come again.
Yeah,
Yes,
operator
Durga, you are
also
saying
may not
something.
having a similar good mood every time.
Competition, market
The 5
competition.
days.
Yeah, market, customer requirement. Yeah, when the customer requirement completely changes, that's an altogether a different challenge. If customer changes his requirement, customer tightens his tolerance, then you have to definitely, enhance your capability immediately, accordingly, in line with the changing requirements of the customer.
Then
But that
entire
is
process
also a
we may
point.
have
That
to
is also a
revisit.
point. In a long term, customer requirement might change. Your process must adapt to it.
Competence management also.
Very good. That is also, yes. Any other factor anybody would like to add? Like morning, all of you were learning very comfortably. But the same thing right after lunch. The situation is different. It's not that easy to retain your capability, isn't it? So unless and until you take proactive measures, want your people to, come prepared for the afternoon session and plan something in extra. Let's say, let's do some activity, some exercise, some hands-on, so that you can be, you can be productive as good as the morning session. Yes or no? The similar efforts are required in your business process also. You may have to have proactive measures to control the raw material variation, to control the variation with respect to the skill level of the operator, to control the machine condition. That is why you need other approaches also. Yes or no? Why do we need TPM? We really don't require TPM if we have to manufacture everything in just 1 hour. What is TPM? Total productive maintenance. ensuring that all our machineries remain in a healthier condition, productive condition. On day 1 and day 100 and day 1000, the conditions should be same. Machine can get aged, but still its condition should be same. It should give the same level of performance. So people who are aware of it and really taking some proactive measures and controls, for those people, even the PPPPK will be similar to CPCPK.
Yes.
You understand? Companies who take proactive measures in arresting all these sources of variation, shift to shift variation, they try to arrest. Supplier to supplier variation, they try to arrest. Even seasonal variation, to the extent possible, you must try to arrest. I mean, the environmental thing. So, if you are actually taking measures to control all the sources of variation, then for those companies, PPPPK will appear closer to CPCPK. Do you understand? In case if you come across a company where PPPPK is far away from CPCPK, let's say CPCPK is 2.22, but PPPPK is 0.87. What do you understand about this company? CPCPK is 2.22, excellent, 6 sigma and above capability. But PPPPK is very bad, 0.8. What does it indicate?
They are not using all their capabilities to perform.
The control plan is poor.
Control plan is poor. Fantastic. Excellent. In one
Maintenance
line,
is
you finish
not
the job. The control plan is poor. The control plan is not actually controlling all the long-term factors which can bring variation in long term. Control plan should not only focus on the factors that can cause variation in the short term. Control plan should also include factors which can bring variation even in the long term. Yes or no? See, we could assess your performance right after the training program, and then we could declare. But if I conduct a similar exam after 6 months, will I be able to witness the same level of capability from all of you?
No.
So that means
may not be.
no. Yeah, in order to really understand our long-term capability, we need to conduct our assessment. See, normally that's why in training effectiveness assessment, they not only conduct the assessment just right at the end of the training program. Certain assessments have to be conducted post 3 months, post completion of the training program. Maybe after 3 months, maybe after 6 months. Certain aspect you will understand only after 1 year. Whether all of you are really successful because of the black belt training program, I can't understand just at the end of the completion of the training program. Maybe after 1 year, if I talk to you, after 3 years, I talk to you, I may get some success stories. But then when it comes to a manufacturing, when it comes to a process capability study, most of the time, the organization will demand us to complete the capability study within the predefined period of time. No companies will be interested in waiting for 6 months and 1 year to understand your performance. Maybe educational institutions like ours, we might talk to our alumni whom we trained 1 year before, or we can come back to all of you after 1 year to understand how you people were performing, and then we can document it. But then in a manufacturing scenario, we would like to understand both capability as well as our performance, by performing the study or by conducting the assessment, capability assessment within a predefined period of time. Sometimes you have to generate a report within 1 day. Yes or no? Next day there is an audit, so you have to submit CPCPK report as well as PPPK report. Sometimes you get 1 week time, sometimes you get 1 month time. So once you understand the conditions, then somehow you have to give your best to assess both CPCPK and the PPPK. Please understand, all of you, your CPCPK as well as PPPK are only estimates, not the exact values of your capability, not the exact values of your performance. Both of them are estimation, estimated value. All of you, first of all, do you understand? your Cp, Cpk and Pp, Ppk are estimated value. Why do I use the word estimated value? Because I'm not really checking each and every part you are producing. I'm only checking a sample of it. So it is a case of inferential statistics. I study a sample, but still I want to judge the whole population. Right? And so it is only an estimation. So try to be at your best. That's the thing, that's what you all can do. If your company gives you only 8 hours time, then you have to utilize only that 8 hours time. Try to collect as much data as possible during that 8 hours time and then proceed with your analysis. All of you are with me on this? So sample size, of course, keeping the sample size at a higher level is definitely a good idea, no doubt. But prior to coming to the sample size, I want all of you to understand very clearly about sample collection period. I think I spoke about this earlier also. Data collection period. Suppose if you have only 1 week time to perform the capability study, then what is your data collection period now available? 1 week only.
1 week.
Because you only have 1 week, isn't it? So next week or the week after the next week, the customer is coming for an audit. So you decided to perform the study for 1 week. Or your customer from Germany has dictated you. Collect data for a period of 1 week. 1 week, I want you to collect sample from every shift. If the customer gives a clear requirement, then you just have to follow, yes or no? Right? So data collection period has to be understood. It can be 1 week, or it can be 3 days, or it can be just 1 day, or it can be just 1 shift, or it can be just 2 hours. In all cases, you should be able to calculate both Cp, and the Pp. All of you understand?
Yes,
Am I
sir.
right? Okay. So, but whatever be the scenario, we will just follow a systematic approach, right? A statistical approach. And then we calculate both Cp, as well as Pp. Imagine a company is performing a study just for 2 hours and then they arrive on a Cp, and Pp. And another company is performing a study for spread over a complete week and they generate a Cp, and Pp report. Which report is more reliable now? Which report is better? A 2-hour study is better or 1 full week study is
1 week.
better?
One
1
full
full
week.
week.
Very good. You must know that which is
Yeah.
better. But still, sometimes you yourself may prefer to perform a 2-hour study. You know why? You really don't have 1 week time. Isn't it?
Short.
So constraints have to be understood and be happy about what is available with you. We only have 2 hours time. So I will spread my data collection over 2 hours only. Or if I have 1 week time, I will spread my data collection for the entire week. Once I understand the spread of my data collection, I need to decide properly about my data collection frequency. 1 week, do I have to collect the data every day or alternate day? Or if it is every day, then every shift. Next requirement is whether I must collect the data every shift. If it is every shift and within the shift I have got 8 hours, should I have to collect the data every single hour or once in 2 hours is okay? You must try to answer all these questions to yourself first. This is known as data collection plan. All of you understand? So spread of data collection, then frequency of data collection, then comes sample size. Then comes sample size. More, if you keep your data collection period sufficiently spreaded, and if you decide on your sample collection frequency with us in a sufficient manner, then your sample size can be between any number between 2 and 25. Any number between 2 and 25. It is always a good idea to collect samples in subgroup. Subgroup means selecting multiple samples simultaneously. I take 5 samples at a time. And then after 1 hour, I take another 5 sample. Again, after another 1 hour, I take another 5 sample. I only have 4 hours. Then every 1 hour, I will take, 5 samples or 10 samples. All of you are with me? And that way, suppose if you really do not have that much time, let us say you have to take the samples only once. If you take the sample only once, so you decided to keep the sample size very high. Let's say sample size 30, or sample size 100, or sample size 200. Since you collected all 200 samples in one go, in your case, you will not be able to differentiate Cp, Cpk and Pp, Ppk. In your case, both of them will be same. But in reality, they will be different. So those of you who are collecting the data in within a very, very shorter period of time, please understand you have to extend your spread of data collection so that you can get a better estimates of both Cp, Cpk and Pp, Ppk. So with that note, let me share my screen. I will, as I already mentioned, I'll be using Minitab as well as the Excel file so that we will have some data to work on, and then we will be conducting the analysis and we'll try to understand. So hope all of you are able to see my Minitab screen now, right? So Cp and Cpk. How are they called? Process Capability Indices. If I type Pp and Ppk, how are they called?
Process
Very good.
Performance Indices.
Very good. Process Performance Indices. Sometimes we call Cpk as short-term capability measures. However, this is long-term capability measures. Okay. And Cp, what is the name of Cp? Potential Process Capability Ratio. Then what is Cpk? Process Capability Index. Similarly, you can name it for Pp, Ppk also. Pp means potential process performance ratio. And here's Ppk means process performance index. Very good. So these terminologies are known. And always, as I told you, when you are performing the capability study, there are few requirements. First requirement number 1, the process you are studying should be under the state of statistical control. Hope all of you understand the meaning of statistical control. Am I right? What do I mean by state of statistical control? The permissible variation is, what kind of variation is permitted?
Normal.
Only common cause variation is permitted.
Yes.
There should not be any special cause variation. Then only you must proceed with the capability study. Otherwise, conducting a capability study will give misleading information. All of you, do you agree with me on that, on this requirement? If the process is under the state of statistical control, then only capability study can give a meaningful interpretation. If the person is not seeking advice, but you still give a lot of advice, and he is not going to listen to you. And it is not a good idea to give any advice for those who are not willing to listen to you. So the process should be in a state of listening. Listening means it should be in a state of your control. We call it statistical control. A process which is under the state of statistical control, you will be able to understand if you monitor the process characteristics in a control chart. If all the points lie inside the control limit, then you can conclude the process is under the state of statistical control. That means the process is listening to you. If the process is listening to you, now you can actually assess and then make suggestion. If the process is not in a state of listening to you, your assessment is not going to make any sense. It is something similar to participants here attending all the sessions. If all of you are attending all the sessions, what does it mean? We have good control over all the participants. Yes or no? Suppose if you are not attending the sessions properly, a lot of sessions you missed to attend, then we want to still conduct an exam to you. Will it make sense? You have not attended any class, but still we are conducting exam and you are getting some mark. What does it mean? It doesn't mean anything, isn't it? So, same manner, if the control chart is out of control, your capability study will lose its meaning. So, how can you avoid? How can you overcome those scenarios? If the control chart is out of control, you must immediately investigate why there is an out of control point. You must take the appropriate action, and the action taken report must be made available. If the action taken report is available, it means the special cause is corrected. In that case, your process qualifies for capability study. If you do not have any kind of action taken report, you only have so many out of control points. Your process in the as it is condition is not even eligible for conducting a capability study. How many of you understand this? Right. Very, very important. Many a times we don't do this check. We straight away believe everything. Whatever the study conducted, we always tend to believe everything. Let's say you are going for an audit. Your company has sent you to audit one of your supplier, and they are showing you a Cpk report. What do you do normally? You tend to believe the report. Yes or no? You will only check what has been presented to you. But even prior to generating a capability report, the company should have maintained the process in a proper state of statistical control. You must ask for a control chart for the last 1 week, last 1 month. If they are able to show you the control chart with everything under proper control, then they show you the capability report. Now the capability report is valid. Otherwise, you are simply reading a report which is invalid. Yes or no?
Yes, yes.
Very good.
So maybe the supplier maybe try to over manage it, so that by the over managing they can achieve the good capability, but long term it may not be.
Correct. Yeah, over managing. But anyway, they have to do the hard work to fulfill your requirement, because your requirement is you have specific requirement with respect to CPCPK, which anyway they have to work hard to achieve it. Whether they achieve it through over managing or they achieve it with the proper ensuring proper capability with the process, that is their smartness. But for me, if you want to be my supplier, yes, this is the bare minimum requirement. CPCPK should be 1.67. And then I will audit you very frequently. And when you go for the audit, you should also ask for the control chart. That is my point to all of you, all the black belts here. You must ask for the control chart before reading from the capability report. Correct? And the control chart should be free from special causes. If it is not, you should also demand the action taken report for every special cause. You get my point? You should demand for the control chart. And then if there are any out of control point, you must also demand for action taken report for each of those points, because the date will be there. Then accordingly, you need to demand for the action taken report. If they are showing a clean control chart, because they very well know you will definitely ask for it. So they show you a very clean control chart. Then what will you do? Then how will you again cross-check them?
Then I can cross check some of the samples there itself.
Very good, very good. Live samples, right?
Yes.
You would like to take samples in real time and plot those samples in the same control chart.
Yes. Yes.
They should also follow the same trend. If the trend is going to be different, then also you could understand they have manipulated something. Yes or no?
Managed it.
Yeah, whatever is the average they are maintaining, they are showing for the last 1 month, the same average you should be able to get with your sample. Sample of 5 or 10 will do. All right. And whatever variation they have been projecting in the control chart, that is why always they maintain 2 control chart. Have you noticed? an X bar chart, which will indicate how the average is fluctuating, and another R chart, which will indicate how the range is fluctuating. Have you noticed it? You need to check for both. The variation should also be under control, and the average should also be under control. And if the same trend is found with your sample average as well as with your sample variation, then you can proceed with the CP-CPK report or PP-PPK report. Hope all of you understand my point here, right? So this is the first
Right.
thing. This is the first thing, check whether the process is under the state of statistical control. And number two, samples must be taken in subgroup. Samples must be taken in subgroup with sufficient with sufficient sampling frequency and sufficient
Period.
sample collection period. So these things you please ensure yourself. Just don't blindly read the report. The report is prepared by performing the study over a week or over a day or over 8 hours or over 4 hours or over 3 hours. You must try to understand. Right? And then how many times samples have been taken during that particular data collection period? Right? Sampling frequency. See, I have seen companies taking samples once in 15 minutes. Once in 15 minutes. And some companies, they take sample once every hour. Certain company, they take sample once every 4 hours. Certain company, they just take sample just at the start of the shift, and then, the next shift only, they will take the next sample. Do you understand? So that must be understood. Only when these two things are understood, you can then proceed with capability study. Clear, all of you?
Clear. Before proceeding for capability study, so whether the data also should be in the normal form, I mean to say the normal distribution.
Yes, your data must be normal. Your data must be normal. Data normal means free from outliers. Yes or no?
Outlier is that again the special cause. Right, sir?
Which are these outliers?
So which
These
are out of
outliers are
the-
nothing but special causes. That is what I want you to verify in the first step itself.
Okay.
Am I correct?
Okay, sir. Okay, sir.
Yeah. All
But
right.
sir,
So,
yes, sir. Because then sometimes there is no outlier. So everything within the control limits. And the data also may not follow the exact normal distribution. Maybe skewed to the left or skewed to the right. So in that
correct.
case also then the data is not normal. Then
Very good. Good question. Can you read the highlighted statement written by me?
sample must be taken in subgroup.
You have to do that. If you are really concerned about normality, because yes, we base our conclusions, all our estimations are based on normal distribution only. So, in order to make sure our data and our statistics follow the normality, you must collect samples in subgroup.
So we
Subgroup
mean
means
understood, sir. So we mean to say that the overall if the sample collection method and the frequency is good, and then the sample will be follow the normal distribution only. No. Am I
come
wrong
again,
or
sir. Come again.
right? So I'm trying to say that if my sample collection method is correct, I'm collecting the sample in the subgroups only over a period of time, then
Very
it
good.
means the collected data will be follow the normal distribution.
Yes, definitely. I'll come to that.
Okay.
There is a theorem known as central limit theorem that comes into picture now. See, subgroup means I always pick multiple samples, right? I pick multiple samples, 2 or 3 or 5 or 10 or 15 or 20. Subgroup means a group of samples, a group of 2 or more samples. This is what we call it subgroup. And the number of samples inside the subgroup is known as subgroup size, right? Subgroup size. And this is nothing but the sample size which we are really concerned about. The number of samples inside the subgroup is what do we actually mean it as sample size. All right. And then your data collection period. I mean, within the available time, let us say you have taken 20 subgroups. Do you understand? Within the data collection period, how many subgroups you have taken? 20 subgroups. Let's say subgroup size is 5. So 20 into 5, totally how many data points you captured? 100.
Good.
100 data points. 5 in a group. The 5 is the sample size. Number of subgroup is 20. Now, you will have something known as subgroup average. Is it possible? Every subgroup will have an average?
Yes.
Right? This is nothing but your X bar chart. We will be monitoring our subgroup average in an X bar chart. Clear? Then every subgroup will also have a range. Yes or no?
Yes, which is R bar.
This is known as variation within each subgroup. This is known as variation within each subgroup. So this is average for each subgroup, which we monitor in X bar chart. The variation with each subgroup we monitor in R chart. All right. Please note, if you have collected the samples in this manner, you simply plot the subgroup averages. You plot the subgroup averages. That will be known as distribution of sample averages. Am I right? How many subgroups you have?
Right.
20. So you have 20 subgroups according to our discussion, right? 20 subgroup. So how many averages you have? 20 averages.
20 averages.
Can you visualize those 20 averages in a histogram? Can you visualize those 20 averages in a histogram?
Yes.
That will have more tendency to follow bell curve. That will have more tendency to follow bell curve. Only factor which you need to optimize is subgroup size. See, your doubt is on normality, and normality will happen if you collect data in subgroup spread over the period of time. And if you have sufficient number of subgroup, and then the subgroup averages, 20 averages, right? For all 20 averages, you can calculate grand average. The grand average is nothing but X double bar. Yes or no? Which is nothing but the center line of your X bar chart. Right? Now, the distribution of sample averages, please listen to my statement very carefully. The distribution of sample averages will always follow normality, provided the sample size is sufficient. Do you understand? I will write for you. The distribution of sample averages will always follow normality, provided the sample size is sufficient. This is known as what? Central limit theorem. This is known as central limit theorem. What is this theorem is telling you? Always the distribution of sample averages will follow bell curve, no doubt. You don't have to doubt. All that you need to take care is some subgroup size or the sample size. And what is the recommendation? Subgroup size should be between 2 and 25. If suppose you doubt the problem with the normality with the sample size of 2, please increase your sample size from 2 to 5 or 5 to 10. Maximum required is 25 only. If you have problem with the normality, keep your sample size towards 25. If you do not have any problem with the normality, your sample size can be as low as 5 or 3 or 2. Have I answered your question?
Yes, sir.
Very good. So now
Understood.
we'll also check this, right? So I'm just opening the sigma level calculator file first. Excel templates. Yeah, here. I'm opening this. Since Cp, Cpk are used widely in manufacturing industry, I am taking an example from the manufacturing industry. But however, please note, Cp, Cpk can be used in any industry. Only requirement is the data type must be continuous data. You should know what is a continuous data, right? A hotel must serve the food at an appropriate temperature. Yes or no? If you go to a restaurant, they must serve the food at an appropriate temperature. Temperature is a measurable characteristics. Now the hotel
Yes.
manager can conduct a capability study, whether he is serving the food at the appropriate temperature or not. What is the range of temperature within which the food must be served? Let's say 40 to 50 degrees Celsius. Now, what is the upper spec? 50 degrees Celsius. What is the lower spec? 40 degrees Celsius. So, the ideal or target temperature is 45 degrees
45.
Celsius. As long as you know the target, upper spec and lower spec and the characteristics is measurable, capability study is applicable. No matter whether you are a manufacturing industry or a service industry. You understand, all of you? All that required is understanding on the data. So now, see here, there is a company where the coating thickness is an important characteristics. You all know what is coating thickness, right? Some kind of coating they are
Yes.
doing, and the customer says the requirement is 50 microns thickness, plus or minus 3 microns tolerance or allowance. So upper spec is 53, lower spec is 47. Upper spec is 53, lower spec is 47. So now the company is loading the, what do you call, the raw material in the form of a roll. In the form of a roll. Every roll, they consume a complete roll to produce 5,000 parts. Every roll is cut into pieces and then coating is done. And how many units they produce? 5,000 parts. Likewise, how many roll they consumed? Can you see here? 25 rolls. Can you see 25 rolls they consumed? All right. So now, in order to understand their capability, whenever they are loading a roll, they have the habit of collecting some samples and studying it. They pick up 3 samples. You see here, from roll number 1, they picked up 3 samples. Can you see the reading of the thickness? And then the roll is completed. Now they are loading the second roll. And from the second roll also, they picked up 3 samples. Likewise, for all 25 rolls, they have a record. Now, totally 25 subgroup of samples they have. Can you understand here?
Yes, sir.
25 subgroup of sample and subgroup size is 3 in this case. Now, I want you to simply copy this. Copy this, coating thickness and roll number. Yes, copy this. Control C. Then you go to Minitab. Place your cursor here and then paste it. Now, I have the same 75 data here in Minitab. And now I want you to go to Stat. Go to Quality Tools. Go to Capability Analysis. Go to Normal. Stat, Quality Tools, Capability Analysis, and then Normal. The description reads like this. Determine how well your process output will meet the customer requirement when your data are reasonably normal. Right? So give normal. Now come here. Now single column. Single column means your column is C1. So click and select. Now subgroup size. Subgroup size we have. What is our subgroup size? 3.
3.
You can either type 3 or you can select this. Minitab will automatically fetch. Now we know it. Let us say 3. And then lower spec. What is the lower specification? 47. Upper spec 53. Specifications must be declared. Then only capability can be estimated, right? So specification must be declared. Now you give OK. Can you see the capability report here? Are you able to see? Process capability report for coating thickness. See here, what is the Cp value? 2.46, 2.37. And the current condition of your process is dotted line. Can you see the dotted line of your process? According to the dotted line, Cpk is 2.46 and 2.37. The capability is above 6 sigma. And look at the rejection, expected rejection. See here, expected rejection, how much units rejected? 0. Nothing is rejected. Everything is 0. Does it mean you will not get any rejection in the future?
No.
25 roles I studied, which is an extensive study. And according to it, there are no rejection, 0 rejection, according to my sample. But still, in a long run, there could be some rejections that you can estimate by just understanding the nature of the curve in the long run. In the long run, you see here the variation is tend to increase. As the variation increases, the spread of the process also increases. Can you see that? The continuous red color curve. Earlier, the control limits of the process were somewhere here. But now, can you see the control limits stretching up to the specification limit? Now, the control limits are approaching the specification limit both on the right side as well as on the left side. On the left side, the tendency is little higher. In order to understand why it is on the higher side, you look at the sample average. Look at the sample average, how much it is? 49 point. Small shift, you can see. Because target is 50, but process is slightly shifted to the left side. As a result, you see in the long run, 293 units are expected to get rejected for crossing the LSL. 100 units are expected to get rejected, and the reason being crossing the upper spec. But how did we calculate? We calculate based on the available data, the 75 data points. The 75 data points. Now, what is the difference actually between the two curves? The variation is the difference, yes or no? Which variation is higher? The variation in the dotted line is higher, or variation in the red color curve is higher?
Red color.
Red color curve.
Red color side.
The variation for the red color curve is known as overall variation.
Or long term.
Long-term variation or overall variation. The variation which you have witnessed with respect to your current process data is known as short-term variation or within variation. The variation within variation, right? So now let me show you the calculations, how we can do everything. And prior to that, let us have a look at our Pp value also. See here, look at the Pp value 1.19, 1.15. And in order to calculate the Cpk, the within standard deviation, how much is the within standard deviation? Look here and tell me.
0.06.
0.406. But if you look at the variation, I mean overall variation, the standard deviation overall, it is 0.83. Can you see the value of your overall standard deviation doubling the within variation? That means right now the variation is under very much control. But in the long run, the variation is expected to at least double it. But how did I understand? How did I understand? Because the simple logic is always in a long run, the capabilities tend to drop. Yes or no?
Yes.
Any process in the long run, the capabilities tend to drop. But unfortunately, I only have 75 data. Now with the 75 data, how can I use this 75 data to arrive on the 0.8? How can I use the 75 data to arrive on the 0.4? Once you know that, yes, you will be able to calculate both Cpk as well as Ppk with the available data only. For calculating the within standard deviation, you have to use the formula R bar divided by D2. R bar divided by D2. Whereas for calculation of overall standard deviation, you have to use all the data points. Totally, how many data points we have? 75. Use all 75 in one go to calculate the standard deviation out of it, which is known as overall standard deviation, right? So now I will show you the same thing with the slides, and then you will be able to better understand.
So just one
Right.
point
Yeah, please.
on the previous screen only.
Oh, in
So
the
there,
Minitab slide, huh? You want
yeah,
it in the Minitab, right?
yes, yes, yes.
Yeah,
So
yeah,
in that,
please.
the short term, the standard deviation is 0.4, whereas the long term standard deviation 0.83. So can we say that in the long term, the capability just will be a half of the current capability?
Yes, that is what you are
Because
seeing
it's
in the
just
report
doubling.
also. You see here, 1.19 is the PP, which is half of your CP.
Yes, the
PPK,
sigma level also. We
sigma
can
level also will come down. Yes.
come down.
Always Cpk multiplied by 3 will be the sigma level. Ppk multiplied by
Yes,
3 will be your long-term sigma level. So 1.15 into 3, 3.45 is the long-term capability, long-term sigma level.
yes, yes.
You're right.
Clear.
You're right. Okay, so now let me take you through slides. I will explain this.
Sir, one more request.
Oh,
Whichever
sure.
you are doing this writing on the Minitab window, na?
Okay, okay.
So
I
I
will share.
request you. Yeah.
Good that you asked now itself. I will copy paste and then share it.
Yes. The previous hypothesis testing as well. The last
That I
if
think I
possible.
forgot to copy actually.
Okay. But
So
the Minitab file itself you can share. Okay.
yeah. Okay. So process capability. Yeah. Oh God. So I will share this. Hope you are able to see my PowerPoint, right?
Yes, sir.
All right. Yeah. Process capability analysis. So this traditional yield, first pass yield, throughput yield, DPMO, Cp, Cpk, you have studied, right? Just simply I'm moving the slides because you are already familiar with that. Yield is simply acceptable output divided by produced output. Whatever you produced and how many accepted, that is your traditional. And the first pass yield is you must subtract the reworked unit so that it is first pass yield. And the throughput yield is applicable when you run a what do you call? This is compound process. When you run a compound process, the output of my first process becomes input to the next. Then input of the next second process becomes input to the next process. So that is known as compound process. When you have compound process, you have to multiply the yield of processes at every stage. Then the resulting value is known as throughput yield, right? That we discussed. And then, of course, the DPMO calculation, defects per these slides also I will be sharing. So the DPMO calculation, you did the GEMS exercise, same manner you can do it for any product or any service. And of course, there is a difference between defect and defective. Defective means you are actually calculating PPM. Defects means you are calculating the DPMO. So now let me quickly go to what do you call this calculation, right? Yes. Yeah. Anyway, I will go back and then run through all these slides also. Yes. Now coming to PPPPK. I have a slide here comparing Sehwag and Surya Kumar Yadav. Suppose you have to make a choice between Surya Kumar Yadav and Sehwag so that they can play in your team. Whom you will choose?
Sehwag.
Sehwag or Surya Kumar Yadav?
Surya Kumar Yadav.
Because you are concerned about the performance, not about their capability, isn't it? In terms of capability, both of them are really good. But performance-wise, Surya Kumar Yadav can do the job. Similarly, between Kapil Dev and Bumrah, we will obviously select Bumrah. Same is the choice between Cp-Cpk and Pp-Ppk. So if you know the purpose, yes, you will make the right decision. Which one to look at? Look at the formula, Pp-Ppk. For formula wise, Cp-Cpk and Pp-Ppk will be same. No difference in the formula. But the type of standard deviation you use, there is a difference. In order to calculate Pp-Ppk, you must use overall standard deviation. Overall standard deviation, you use the simple formula, square root of summation of x minus x bar the whole square divided by n minus 1, where n is the total number of samples you have taken, right? If there are 75 samples you have taken, n will be 75. And Ppk, it's nothing but the minimum of Pp upper or Pp lower. And now, yes, this is what we have seen, a dotted line and the red color curve, dotted curve and the red color curve. Now the capability is a function of the position of the center of the process. Here the center is almost same, but the spread wise there is a difference. Wow, from the initial study, the spread within the current condition is minimal, but the overall spread is getting maximized. So there are two things important to understand the capability. One is variation, the other one is position of the center. Accordingly, we have short-term capability, we have long-term capability. If you want to calculate short-term capability, you must use a type of standard deviation known as within standard deviation. The type of standard deviation is known as within standard deviation, which is nothing but R bar divided by D2, where D2 is a statistical constant that depends on your sample size, particularly subgroup size. Since in our example, the subgroup size is 3. For a subgroup size of 3, we need to use the value D2. And hence R bar divided by D2 will give you this within standard deviation. There is one another standard deviation which is known as overall standard deviation. Actually, in addition to the within and overall, there are two more standard deviation you can see here. One is between and then one is combined. We'll try to understand this little later. Now let us try to understand within and then overall. If you, after calculating within standard deviation, if you use this standard deviation to calculate the, the capability indices, then it will be Cp-Cpk. If you use overall standard deviation and then calculate the capability indices, they will be Pp-Ppk, right? They will be Pp-Ppk. And there is one other capability which Minitab will also generate, include in the report, which is known as within between capability. So we will come to this little later. Right now, let us try to understand the difference between within and the overall. And this is what is the short term is Cp-Cpk and the long term is Pp-Ppk. And of course, this is the formula again for your notice. And always when you want to conduct a capability study, make sure your process is under the state of statistical control. Right? And also, if you want to understand your short-term capability, look at Cp-Cpk. If you want to understand the long-term capability, then you need to look at your Pp-Ppk. So you need to understand your requirement. If you are going to audit one of your supplier, then you might expect long-term performance. Yes or no? Because you are going to renew the contract. Next 3 years, the fellow is going to supply you the product. So you must definitely demand for a Pp-Ppk. Right? Suppose if the requirement is not for, let us say, not for next 3 years. Let's say the requirement is just let's say 300 parts. Now you can even settle with the Cp-Cpk. Do you understand what I'm telling? I just need 300 child components. 300 child components can be produced in just 3 hours time. Which metric I will now demand? Will I demand Cp-Cpk or Pp-Ppk? Cp-Cpk, isn't it? Because I just need 300 parts from that fellow. And if his currently settings are okay, I'm okay. I'll buy the 300 unit. That's all. But if I have to sign a contract for the next 3 years, I will certainly demand for Pp-Ppk. So you must know your requirement first of all, which one to look at. But if you are not clear, then the better one is Pp-Ppk. Hope all of you understand. Okay. So now coming here, the same data point. See here, quoting 25 roles, and from every role, we have 3 samples. Now, how Minitab is calculating? Let us do some homework and then let us manually calculate so that, you will better understand the report generated by Minitab. Number of subgroups is nothing but 25. subgroup size is 3. So total number of data 75. Now with the 25 subgroup, for every subgroup, I want you to calculate range, which is known as range within subgroup. Range formula is very simple, maximum minus minimum. Say for example, if you consider the first subgroup, which is the maximum here, 50.40, which is the minimum here, 50.14. So you can calculate a range within the first 3 samples. If the range is minimal, how many parts you produced from roll number 1? Let's say you produced 5,000 parts. Now the quality of, if the range is minimal, then these 5,000 parts produced from roll number 1 will be more or less same. The consistency will be higher. That is the point. And now the range within the subgroup is calculated for all 25 subgroups. Afterwards, you need to calculate, you need to convert this variation into a form of standard deviation. But what kind of measure you have right now? Range. Hope all of you know there is a relationship between range and standard deviation. Can one of you tell me what is the relationship between range and standard deviation? Range is maximum minus minimum. Range is maximum minus minimum. When you have a sufficient amount of data, the maximum point is nothing but upper control limit. The minimum point on the left side is nothing but lower control limit. So the difference between maximum and minimum is equal to what?
Range.
Is equal to range. In other words, the upper control limit will be at a distance of how much from the center? 3 sigma.
Yeah, 3 sigma.
Similarly, lower control limit will also be 3 sigma. So range is equal to 6 sigma. Can you see that? The range is equal to 6 sigma. So range and standard deviation are related. But what is important is sufficiency of the data. This relationship will hold good only when you have sufficient amount of data. To overcome the limitation of having a lesser number of data, statisticians have introduced some constant using which you can convert the range into standard deviation. Do you understand, all of you, why the constant is coming? So formula here is R bar divided by D2. So what is R bar? All 25 ranges added and divided by 25. That will be the R bar. After that, you have to divide that R bar by D2. D2, what is written here? 1.693. See here, there is a table which includes statistical constants for control charts. For a sample size of 3, the D2 value is how much? 1.693. So you divide your R bar by 1.693. That will give rise to 0.4139. This is what is denoted as sigma within in the Minitab report. All of you understand? What Minitab has calculated, now we have calculated ourselves. But what is this very standard deviation known as? Within standard deviation. It represents variation within each subgroup. If the variation within each subgroup is minimal, you can trust all the parts produced during that period. Do you understand? The variation within the subgroup is very, very minimal. That means you can trust all the parts that are produced during that period, right? So similarly, another thing you need to calculate, which is overall variation. What is overall variation? Totally how many points? 75 points. Can you put all 75 points in just one column and calculate a standard deviation out of it? Excel has a formula, isn't it?
Yes,
Standard deviation dot S and select all 75 data and try to understand how much it is coming. This is coming to be 0.83. That means in the long run, variations are expected to be at least double the amount of variation which you have witnessed in the long run, in the short run. Do you understand? In the short term, according to the period of data collection, the variation is only 0.4. But in the long term, it is expected to double. That means in the long term, your capability will come down to half of the current capability. But how much time, sir, it will take, that you have to judge. What is short term and then what is long term? That you have to judge. If you are every shift to your company, if it is producing only 1,000 parts, maybe long term, maybe for 2 months. But every single shift your company is producing 10,000 parts. then the long term can be just next week. Do you understand? The more the number of runs you execute with respect to your process, if it is more, then the tendency that your process can shift will be higher. The tendency that the spread of the process can increase will be higher. You have to judge all of this by studying your condition of the process. So sigma overall is 0.8384. If I simply substitute the 0.8384, I will get PP as 1.19, Ppk as 1.15. which is half of the Cp/Cpk. If I only require the short-term capability, then I should be happy about my process capability. If I am really concerned about my long-term performance, because I have a contract for next 5 years, now I will definitely demand for some improvement. Do you understand, all of you? And if improvement is not possible, then I have to perform the capability report very frequently, Cp/Cpk report. Do you understand? Still, see, if Pp/Ppk, if you are not able to achieve, then what can you do is, you have to perform the capability study probably every week. Because maintaining the performance over the next 1 week is definitely possible. But if you really don't want to stop your production for performing the capability study, then try to achieve a Pp/Ppk before starting your production. If you get a Pp/Ppk during your what you call the pilot production itself, then you don't have to stop your process. You can keep on producing everything in one go. So that is the idea. Hope all of you understand how that calculation worked. And this is the table where you can pick up the statistical constant. You can see here the statistical constant depends, the sample size depends from 2 to 25. This is what I told you. Right? Sample size. And now look at our process data. Look at our process data. Is it under state of statistical control? Under the state of statistical control or not?
Sir, why we are
This is
selecting
outcome.
for D3, sir?
Why we are selecting?
For D3.
Yeah. D3, see, this is a method developed by statistician. D2, we actually selected D2. D2 is 1.693. Because the formula is R bar divided by D2. D2 is a statistical cost. See here for sigma estimate, because we want everything in sigma. But what we have calculated is range. So I have to convert the range into sigma. So how do I get? By dividing the range by some factor. That factor is 1.693. That this number is researched, and then they have designed this table based on the sample size. For every sample size, the number is already available. You can readily use it.
So we don't have to calculate this D2, right?
D2 you don't have to calculate. D2 is available in the table. You can, even if you Google it, you will get the same table only. Somebody has done research and found out the relationship between range and standard deviation, and they realized your range will be, somewhere between what do you call the range will definitely have a relationship with sigma and with the expression R bar by D2, and D2 will be in this range 1.12 to 3.9. But if your sample size are more, if you have sufficient, good number of samples, then the original understanding will happen. R equal to 6 sigma.
Okay.
Right? In that case, sigma will be equal to R by 6. But here we don't divide by 6, we divide by 1.693 because we are working with the sample size of just 3. So this particular process is clearly having a lot of out of control points. You can see here. So for every out of control point, R chart is in perfect control, but X bar chart is out of control. So for every out of control point,
Table.
some action is required. Some action is required. Once that action is taken, you can remove this point. You can remove this point, and then with the remaining point, you can perform the capability report. But if action taken report is not available, or if the actions are not taken, process is simply performing in this manner, in that case, your Cp/Cpk will give a misleading interpretation. You can't, the trustability is very, very low. So it is better to avoid reading the CP/CPK report if your process is running in that fashion. So all of them are out of control points. So process is statistically out of control. So strictly speaking, in this condition, CP/CPK study should not be conducted. Prior to that, you need to rule out all of these out of control points. After that, you proceed with your CP/CPK study. And this is the Minitab report, what we witnessed, like the dotted line and the, what you call, the red color thing. And this dotted line actually represents the current condition. However, in the long term, it can become the red color one. There is Pp/Ppk is 1.19 and then 1.15, Cp/Cpk is 2.46. See here, current rejections are 0, but still expected rejections are 393, out of which 293 on the left side and 100 is on the right side. So the same thing, again, in another format of Minitab report, within capability, and then this is known as within capability and overall capability. The within capability is, within capability is Cp/Cpk, the overall capability is Pp/Ppk.
What is
All right.
PPL and U?
Like Cp/Cpk, we have Cp upper and Cp lower, right? CPU means Cp upper. CPL means Cp lower. Same manner for Pp/Ppk, we have Pp upper and Pp lower. So now I will also show you the Excel calculation also. Excel sheet. And you can also go through the...
CPM also is there, sir.
Yes.
CPM. What is CPM?
Oh, CPM. CPM, I think that is for the machine, right? Machine capability, we call it. Once again. So now that I brought you to the Excel, you see here. So all 75 data points are typed in column number 1. You see here all 75. All 75. And for all the 75, I calculate standard deviation. How to calculate standard deviation? Standard deviation dot S. From here until this level, I close the bracket and enter. Are you getting this 0.83? This is overall standard deviation. All 75 in one go. But look here, the calculations for the, what do you call, within standard deviation. Subgroup 3. Subgroup average is average of the first 3. This 3 average is written here. And subgroup range means maximum within the 3 minus minimum within the 3. So this is the subgroup range. This is known as R1. Then what is this? R2, R3, and so on. Totally it comes to 25 ranges. You see here. 25 ranges. For all 25 ranges, I calculate the average. When I calculate average of the ranges, what is it known as? R bar. Yes or no? After getting R bar, the formula says R bar by D2. You see here, R bar by D2. But what is D2? 1.693. We picked up from the table. Yes. So this R bar value should be divided by D2. This 0.700 we divide by 1.693. That gives me sigma within 0.4. Once I get sigma within as 0.4, then I get my Cp as 2.41, Cpk as 2.32. This Excel file you can also open and then you can try to understand all the calculations I did in a manual manner also, so that you will get a better understanding. So if there are any questions you want to ask now, please ask. Now I will show you a few more additional slides so that you will have much more clarity. Okay, any questions? Yeah, please.
That Minitab report, can we select whatever the parameters we want to display on that report of the CP/Cpk? Right now we
Yes.
have a
Come on.
If I don't want to show, I want to show only Cp or Pp then
Oh, you don't want to show Ppk,
yeah.
No, I think it will show always Cpk along with the Ppk only.
Okay.
It will show along with the Ppk only. You can't avoid. But whatever required, that you can read. Whatever required, that you can just read those things. Okay.
Okay.
So this the standard deviation which we have calculated through the Excel std.s. So that will be a long term. So with that, if the capability will be calculating, that will be Pp Ppk only, right, sir?
Come
It will
again,
be
come
depending
again.
on the standard deviation.
No,
So
I'm not
because the
getting you.
formula, yeah.
Hmm.
So the formula for both the indices, Pp
Yes.
Ppk and Cp Cpk is same, right, sir? But
Yeah,
the
yeah.
sample
Formula
collection
wise, they are
method
same. Formula wise, they are
are
same.
same. So I'm coming to next point. So it depends on the standard deviation only. So
Yes,
if the
exactly.
standard deviation, which we are calculating that through Excel, the stdev.s, which is giving
Yes,
me the
correct.
long-term standard deviation. So if I'll be calculating capability with that standard deviation, it will be giving me the PP and PPK only, right, sir?
You're right. You're right. Correct. You're right.
And
And
if I'm calculating by R by D2, then it will be a CPCPK.
very good. Correct. Your understanding is perfect.
Okay, thank you, sir.
Yeah. How we make use of the data, that is what is important. If we use all the data in one go, then it is what you call the PPPPK. If we
Yeah,
divide the data in subgroup and then go with the subgroup wise range and then convert that into R bar by D2, then it is within standard deviation, then that will give rise to CPCPK. Okay.
yeah.
So
Before
now,
that, actually, sir, I was having understanding that whichever capability, even with this the long-term standard deviation, I'm calculating. So I may
mm,
have to add this 1.5 sigma. Then only I will be getting my long-term capability. Before that session, I was having that understanding. I hope you
mm,
understood my point, sir.
yeah, I know. See, once you get a sigma, that is, see, statistics is an approximation, little approximation is involved. That is one way. One way we can find out our long-term sigma level is by adding 1.5 with the
1.5.
short-term sigma level. But this is very,
Yes.
very, what to say, approximate way of doing it. But since you have the continuous data and you can, from the data only, you can directly measure the long-term capability. So you don't have to add a plus or minus 1.5 and other things. Rather, you calculate CPCPK to understand your short-term capability, calculate PPPPK to understand your long-term capability. You don't have to
Okay.
actually use that 1.5 method. People who don't know the purpose of PPPPK, they will use that method. That is for them. But for us, we can use PPPPK.
Sir,
Good.
I have one question actually.
Please.
Uh, can you please tell once again what is X bar and what is R bar in a brief? Because you are saying too fast, so it is very difficult to register everything.
Okay. So X bar represents sample average or subgroup average. R represents sample range or subgroup range. R represents the variation within the subgroup. How many sample in our discussion? 3. If your process is under extreme higher level of control, let us just for discussion, let us assume all the 3 parts gave the same value. Then what will be the range? If all the 3 readings are same, range will be
0.
0.
Range will be
Range
the 0.
0 is difficult to achieve. Can you see that? If you have extreme higher level of control, then only the variation will be 0 or minimal. So you must try to get a very, very lower value of range. The within variation should be very, very low. So that you can say that you have good control over the variation within your period of study. Right? So that is known as, first of all, you must have a understanding about within and overall. In our example, what is the meaning of within? If the within variation is very low, then variation within the 5,000 parts I produced will be very low. Am I right? Because from every roll, how many parts I produced? 5,000 I said. So if the variation within the 3 samples are minimal, it can be interpreted as the variation within the 5,000 parts will also be minimal. Suppose if the variation within the 3 is very high, then I will not dispatch those 5,000 parts. I will immediately stop the dispatch. If a particular point in my R chart falls outside the control limit, you know what will I do? If my R chart is out of control, then I will not dispatch that particular lot. I have to do 100% inspection. All 5,000 parts I have to necessarily check and then separate the good and bad, and then only I will dispatch those 5,000 parts. Do you understand? I mean, not even 5,000. I will separate the rejected parts and the good parts only I will dispatch. Okay. So let me show you some simple examples. Now you will be able to better understand. Yeah. Anything you want to ask, please ask.
That's only a simple question. If they regarding that control chart constants, up to 25 we have a value. Above 25, we are going to directly 6 or any other thing.
Now up to 25. Sample size, the control chart constant is available up to 25 only. That is more than enough.
Okay.
And normally, sample size will be below 10 only in many scenario. But only if required, you can go about 10. Maybe sometimes 12, 13, 14, 15, and up to 25 is. See, ultimately, I expect my sample average to follow normality. I expect my sample variation to be following the bell curve. That is my requirement. So 25 is on the higher side. See, sometimes if you take too many samples, also, companies may not allow you. So the sample size is limited to 25 only maximum. Definitely not required beyond. If you want more sample, increase your spread of data collection. Increase your sampling frequency. That and all you can do to better understand, but sample size need not be more than 25. So now let me show you some few simple slides and which will simplify your understanding. See, normally when we are designing a process, right? When we design a process, we wanted to design a process in a, what do you call? In a easily manageable manner. Yes or no? The process must be easily manageable. So let me play this video and then you have to judge whether this is easily manageable or difficult to manage. Tell me, what do you understand about this process? Easily manageable or difficult to manage?
Difficult.
Difficult.
Why it has become difficult?
It's
Why it
not
has
easy
become
to get
difficult?
inside. It's not getting easily inside.
Yeah. Why? Because the tub size and elephant size are more or less equal. And here the, what do you call, the elephant is fixed, but tub is under your control. Now, in order to make it easily manageable, what you can do is think of a bigger tub. Create a bigger tub. The process will become easily manageable. That is what you are seeing on the other side. You see here. Now it has become easily manageable simply because you increased the tub size. When it comes to a business process, there are two things: customer provided tolerance. That is known as specification width. And your process will anyway will have a spread. That is known as process width. Now, which is under your control? Specification width is under control or process width is under your control?
Process only.
Process within our control.
So make sure your process width is smaller than the customer provided tolerance. So what will happen? Your process will become easily manageable. If you allow your process to play throughout the entire range of tolerance given by the customer, it will be very, very difficult to manage, right? It will definitely become a problematic. And this is what we have been discussing right from the beginning. See here, the parking area, right? The tolerance provided by the customer is the width of the parking area. Now your process by nature will have certain spread, yes or no? That I am denoting here by the width of the car. If my car is bigger than the parking area, do you think I can park the car easily? No. It is going to have definitely damages. So if you run any process with a spread higher than the customer provided tolerance, it will certainly lead to rejections, right? And so the better scenario is this one. But most of the business will operate in this manner only. You know what is the situation here? The parking area width and the car width are
Neck to neck.
close to each other, neck to neck.
Just
This
neck
is
to
how many of the business process will be running. This is what they call it as 3 sigma capability. If the car size is equal to the size of the parking area and you have to park your car 1,000 times a day, do you think you will make a safe parking every day?
No. One day there will be scratch.
Occasionally parking is okay. But if you have to park very frequently, you must prefer the third scenario, where third scenario, the car size is half the size of the parking area. That means your car occupies only half of the tolerance provided by the customer. Similarly, if your business process also should not try to consume all the tolerance given by the customer, it should consume only half the tolerance. If it consumes all the tolerance, the capability is 3 sigma capability, the second scenario. Right? Just capable scenario. But if it consumes only half of the tolerance, double capability, it is like your earnings and expense. If your earning is 2 lakh and if your expense is also 2 lakh, which scenario you are in? You are in the second scenario. You are earning 2 lakhs, that's a good money. But how much you are spending same month? All 2 lakhs, isn't it? So any emergency expense comes, will you be able to manage? You will not be able to manage, isn't it? So what is required is, if your earning is 2 lakh and if you limit your expenses to less than 1 lakh, you are creating this scenario, doubly capable scenario. Doubly capable scenario means 6 sigma capability. Here the Cp Cpk equal to 1. Here the Cp Cpk equal to 2. All of you understand? So same thinking is required, while running any process also. See here, there is a pilot. He has to land the aircraft in the runway. Now, can you see a center line drawn in the runway? And which is the safest point to land? And the runway is ending here. That is an indication that your runway is ending here, and so that can be considered as upper spec. Then what is this? Lower spec. Now the pilot, in order to understand the capability of the pilot, we are asking him to land the aircraft several times. Can you see all his landing points are happening around the center only? Now tell me whether the pilot is capable or not.
Yes.
Definitely capable, right? Because he understood your requirement. You want to have a safe landing. And the pilot is very much capable because all his points are closer to your target. This is what we are checking in the X bar chart also. In the X bar chart, what is the center line? X double bar. The X double bar should be closer to the customer provided target. If that is not happening, your process is shifting. Here you can't say process is shifting. Am I right? He is having a balanced. Can you see that? Now I am showing you few more landing point. What is your comment about this landing point? This is deviated on the right side. Yes or no?
Yes.
Now few more landing points. Now the landing points are on the left side. Now few more landing points. Now few more landing points. After sufficient number of landing points, you are now able to understand what is the nature of the data now. One of you asked the question, right? Sir, bell curve will come or not? It depends on the amount of samples you work with, right? Once you have sufficient amount of samples, definitely any data will, particularly the measurable data, will follow bell curve. Why the bell curve is taller in the center? Can somebody answer this question? Why is it taller in the center?
Because of
Mean
the
value
knowledge
is
the customer
Most of the
target.
points.
Distribution
Because
is
the
equal.
pilot wanted to land in the center of the runway, most of his landing points are around the center line. If you suppose fly with a poor pilot, then he might try to land you somewhere here, which is very risky. Yes or no? And so this is the customer target. And what is this? In order to understand whether your process is targeting the customer target correctly or not, you must calculate process average. You understand? The process average and customer target must be close to each other. If they are aligning, that's the perfect scenario. Now, what is this limit? The maximum landing you can expect from the pilot is the maximum worst landing you can expect from the pilot is here. This is what we
Upper
call it as
control.
upper control limit. Similarly, lower control limit. If everything goes wrong, then pilot might still land you here and here. Then also it is safe landing. Can you see that? So this is your upper spec and this is your lower spec. Whenever in any process, if you are able to see the control limit inside the specification limit, you can declare the process capable. Right? And also by knowing the control limit, you can understand how much tolerance you have consumed. If you are consuming less than half of the tolerance, your process is Six Sigma capability and above. If you consume all the tolerance given by the customer, then you are just capable. Hope all of you understand. Customer target, upper spec, lower spec, upper control limit, lower control limit. So what are the learnings here? Process average and customer target should lie in line. Yes or no? They must appear together. And variation in your process is an unpreferred event. More the variation, more chances of failure. So spread in any process should be minimal. And whenever your process produce an output beyond the specification limit, customer himself will reject your product. That is what we call it external failure. But whenever your process produce an output outside the control limit, you must proactively take action. I repeat the statement. Whenever you see an output getting produced outside the control limit, you must proactively take some action. You know why? Even though my control limit is inside the spec, my customer is not going to reject. But my process producing an output outside the control limit should be treated as an unpreferred scenario, isn't it? Because producing around the control limit is not really a good output. Even though it is inside the spec, it should be considered, yeah, what do you call it? A special cause and action is required. Okay. And have you played this game? Shooting a balloon in the beach? You might have played,
Yes.
right?
Yes.
So now if I give you a gun and ask you to shoot the balloon at the center, what is the color of the balloon at the center?
Red.
What is the color?
Red.
red is
Red color. I will give you 10 bullets. If you shoot all 10 bullets and hit this balloon repeatedly, I will give you 10,000 rupees. Do you understand what is expected from you? You have to hit the target exactly only one option, only the red color balloon in the center you have to hit, and that you have to repeat it consistently with every bullet. So primary requirement is you should first of all know how to hold the gun. If you don't know how to hold the gun, suppose you hold it like this, will you be able to hit the target? This is what we are checking with the X bar chart. The center line in your X bar chart should be where? Should be on the customer target. What is customer target? The midpoint of Upper spec and lower spec.
Upper
All of you
spec,
agree
lower
with me?
Yes.
Yes.
So the X double bar should always appear on the customer target. That means you know how to hold the gun. Now you have to release the bullet. Oh, first time it is hitting. Now second time. Second time also it is hitting the same thing. Third time also it is hitting. That means I have very good control. First shift day, second shift day, night shift day shift day. Whenever I produce, it is hitting the target. That means I have a very effective control plan. But in reality, making it happen is not that easy. Yes or no? You all know, you all agree with me. So what will happen? If you tend to lose control by a little margin, instead of hitting the red color balloon at the target, your bullets might hit any of the balloon in the first circle. Possible or not?
Possible.
Suppose if you tend to lose the control further, your bullet might start hitting the balloons at the second circle. You are not taking any action. You tend to lose control further. Now your bullets will start hitting the balloons at the third circle. You are not taking any action now also. Now what will happen? Your bullets will now start hitting the audience who are sitting in the area. Do you understand? Earlier, you are only missing the target and still you are within that, what you call, the board. But now you are missing the complete board and you started shooting all the audience. Do you think audience will keep quiet and allow you to continue?
No.
Definitely no. This is what
No.
we are also demanding with the control chart. As long as your points are inside the control limit, you are shooting within the board. But the moment a point falls outside the control limit, you have lost your, what you call, the professionalism in your process. Yes or no? So, whenever you see a point beyond the control limit, you must immediately stop the process and try to understand the root of the problem. Try to understand whether the root cause is a recurring root cause. If the failure is recurring, definitely some action is required. If it is non-recurring, just try to understand what it is, and then you can proceed. So that is why knowledge on the normal now all of you understand why the bell curve, the knowledge on bell curve is required. And see here, you all know this particular thing, isn't it? If you look at the bell curve, the blue color area accounts to how much? 68% of the population. And blue and brown, that accounts to 95%. Blue, brown and green, that accounts to 99.73. So you must have some good understanding. See, when the pilot was landing on the runway, approximately half of the landings were on the right side of the center line. Approximately half of the landings were on the left of the center line. The same thing is what you are seeing here in the bell curve also. The bell curve is symmetrical at the center. And now customer specification is declared like this. Oh, sorry. Customer specification is declared like this. And your process is performing in this manner. You see your control limit somewhere here and somewhere here. Now tell me, is this process capable?
No,
sir.
No,
No,
sir.
sir.
No. In a long term, we can lose.
In long term, you may lose. But right now, it is capable, right? And now tell me, my process is still capable or not?
Not capable.
In
Yeah,
short term,
capable.
no, see, in short term, it is capable. Your idea is correct. Short
Yes.
term, it is capable. Long term, yes, we need to understand. There is a shift to happen. But right now, the process is shifted to the right side. So if you allow the process to shift further, it will start producing rejections. And now tell me, the whole process is operating inside the specification, looks to be capable. However, the process is shifted to the left side.
Left.
Or shifted to the left side. But now look at the condition. I see my process having spread beyond the specification limit. So there is a rejection happening on the right side. There is a rejection happening on the left side. In the short term itself, there is a rejection. So in long term, there can be much more rejection.
Yes.
Very good. So this is what we are actually, trying to understand. What is the current condition? What will happen if my process spread increases further? What will happen if my process completely shift to the right side or completely shift to the left side? This is in order to judge the long term, we found a way to calculate Pp, Ppk, and then, we estimate the probability of success and the probability of failure. And this CP-CPK story, you all know. So this is CP-CPK wise, it is capable. And here the process is shifted to the right side, but still it is performing. Oh no, now it is exceeded the specification on the right side. And so there are some rejections. Here everything is inside. Process is completely capable. CP also good and CPK also good. CP-CPK will be same if your center line is, if the process is not shifted. Here the process is shifted, so CP-CPK will be different, right? CP-CPK will be different in this case. So always you need to aim for a CPK value of 1.67 and similarly CP value of 1.67, and in an ideal scenario, CP will be equal to CPK. So this is what I just wanted to discuss with you. And now if there is anything you would like to ask, yes, you can ask. I'll be happy to answer your questions now.